Hey and welcome to a demonstration video of emergency NGX from FS2 crew. In this video I want to show you two procedures because they go normally hand in hand. It's a cabin altitude warning or rapid depressurization procedure followed by an emergency descent. The cabin of the 737 is pressurized by bleed air through the air conditioning system and is controlled by an outflow valve that regulates the outflow of air such that the cabin altitude is as desired. If a rapid depressurization occurs, the crew has to do the following items. They have to don their oxygen masks that supply the passengers with oxygen masks. They have to close the outflow valve manually, and then depending on if the cabin altitude can be controlled or not, and if the altitude is actually exceeding 14,000 feet or if it is below, one has to actually do an emergency descent, and this will be done by putting the engine start switches to continuous. Then the thrust levers will be reduced to idle or whatever is needed for the anti-ice. The spoilers will be raised and one will descend to 10,000 feet or the minimum safe altitude, whichever is higher, on the highest safe speed. It's actually not possible to don the oxygen mask on the PMDG 737, but just to simulate the situation a bit, I will push the red button here, and now we can activate the failure. You once again go to the menu and then to PMDG setup, aircraft and failures, and on the last page you will find pressurization. And there you go to pressure hull integrity, and this is the failure we want.
Okay, master caution, air conditioning.
Cabin altitude warning or rapid depressurization memory items.
Check. Cabin altitude warning or rapid depressurization checklist. Condition: one or more of these occur. Cabin altitude exceedance. In flight, the intermittent cabin altitude configuration warning horn sounds and the cabin altitude lights, if installed and operative, illuminate. Okay, the memory items: don oxygen masks and set regulators to 100%. Establish crew communications. Okay, I've got you loud and clear. Pressurization mode selector manual. Outflow valve switch. Hold and close until outflow valve indicates fully closed. Is the cabin altitude controllable or not controllable? Okay, not controllable. Passenger signs on. Is the cabin altitude exceeding or is it expected to exceed 14,000 feet? Okay, I concur. Passenger oxygen switch on. Go to the emergency descent checklist on page 0.1. That's the cabin altitude warning or rapid depressurization checklist complete.
Emergency descent memory items.
Check. Passenger signs on. Engine start switches both continuous. Emergency descent memory items complete.
Emergency descent checklist.
Emergency descent checklist. Condition: one or more of these occur. Cabin altitude cannot be controlled when the airplane is above 14,000 feet. A rapid descent is needed. Memory items: announce the emergency descent. The captain will advise the cabin crew on the PA system of impending rapid descent. The first officer will advise ATC and obtain the area altimeter setting. Passenger signs on. Without delay, descend to the lowest safe altitude or 10,000 feet, whichever is higher. Engine start switches, both continuous. Thrust levers, both. Reduce thrust to minimum or as needed for anti-ice. Speed brake, flight detent. Caution, if structural integrity is in doubt, limit speed as much as possible and avoid high maneuvering loads. Set target speed to MMO, VMO. Reference items. When approaching the level off altitude, smoothly lower the speed brake lever to the down T-tent and level off. Add thrust and stabilize on altitude and airspeed. Crew oxygen regulators, normal. Flight crew must use oxygen when cabin altitude is above 10,000 feet. To conserve oxygen, move the regulator to normal. Engine start switches, both, as needed. The new course of action is based on weather, oxygen, fuel remaining and available airports. Use of long-range cruise may be needed. Emergency descent checklist complete.
I did not announce it now to the over the PA to the passengers that we are doing an emergency descent, but I think that is acceptable because we don't have actually real passengers. However, if you're flying on VATSIM or any other online environment, you would actually need to inform ATC over your proceedings. And this will be normally, I think, the duty of the FO, but FS2 crew can't yet talk to the ATC. And the minimum safe altitude for this area is about 8,500, so we're choosing 10,000 as our target altitude. As you can see now, the cabin altitude is once again dropping from the values above here from to below 20,000 feet, and is still descending, so this is good. If you are actually flying in areas like the US, where your transition level is about 18,000 feet, then you would actually need to acquire the local UNH and to set it into the altimeter. But I'm flying in Europe, and there it's mostly about 7,000, 8,000 feet, so we're still in the flight level region with our 10,000 feet.
Flight level 100.
I turned down the speed now to 250 knots, since that is the maximum allowed speed normally when you are below or at 10,000. As you can see, the cabin altitude is now at 10,000 feet as well, so we're in a safe region, and now we would need to talk to ATC and actually decide on our further plans if we divert to an alternate or if we continue to our final destination. If you want further information on the 737 systems and procedures, I recommend smartcockpit.com, an open access library where you'll find a lot of information, or angle of attack videos that you can fly on flyaoamedia.com, and I put both links in the video description. I hope you enjoyed the video. Thanks for watching, and bye.